the light under your skin. You have stood in morning sunlight and changed your body before you felt warm. Within the first 90 seconds, blue wavelengths striking melanopsin, a light-sensitive pigment inside a special set of retinal ganglion cells, had already started resetting the suprachiasmatic nucleus, a paired cluster of neurons above the crossing of your optic nerves that keeps your daily time, while ultraviolet photons hitting 7-dehydrocholesterol, a molecule waiting in your skin, had already begun a separate chain of chemistry. You called that brightness. Your body treated it as command and construction at the same time. The unanswered part is why a star 150 million kilometers away can reach into your hormones with that precision, and why the light touching your face that morning was already ancient before it crossed the sky. Remember the quiet rectangle of sun on a floor. It returns at the end as evidence, not scenery. Sunlight alters you before sight becomes thought. Most people treat daylight as visual background, a neutral condition that simply lets the world become visible. Yet your body uses it as a control signal long before language catches up. Hold your hand in a patch of sun. The warmth is late. The message arrives first. The mechanism begins in phototransduction, the process in which pigment molecules change shape after absorbing photons and trigger electrical signals in living tissue. In plain terms, sunlight strikes matter in your eye and skin, moves electrons into new arrangements, and forces molecules to behave differently because the energy arrived in exact packets. Those packets are photons. A photon is not a tiny glowing bead. It is a measured unit of electromagnetic energy that matter can absorb only under very specific rules. When melanopsin absorbs blue-rich daylight, the cell containing it changes its electrical state and reports dawn to the brain even if you never look directly at the source. When ultraviolet B reaches your skin, the energy bends a carbon bond inside 7-dehydrocholesterol and starts the multi-step manufacture of vitamin D. Your retina and your epidermis do not passively receive light. They negotiate with it. In 2002, David Burson and colleagues described intrinsically photosensitive retinal ganglion cells, the cells that respond to light directly rather than borrowing information from rods and cones. That finding mattered because it proved that part of your visual system serves timekeeping before image making. The eye does not only see, it schedules. Sunlight is already inside your biology before it becomes a view. That is not a metaphor. That is the biology. Every morning you open your eyes, your brain receives time before it receives scenery. The next problem is harsher. Your body is not reacting to all sunlight equally, and the sky has been editing the message above you the entire time. Morning, a command signal. Morning light is a timing instrument. That clashes with the common fiction that your schedule, your discipline, or your alarm clock governs when you wake and when you sleep. Those things negotiate with your habits. Sunlight governs the deeper machinery. Step to a window and face the brightest part of the sky without looking at the sun. Your pupils tighten, but the more consequential event happens behind that reflex. Blue-enriched morning light drives melanopsin cells hard enough to signal the suprachiasmatic nucleus, and that nucleus synchronizes peripheral clocks throughout your body. A peripheral clock is a biochemical timer inside tissues far from the brain. In physical terms, liver cells, gut cells, immune cells, and fat cells all cycle through predictable changes in enzyme activity and gene expression, and morning light lines their rhythms up so they do not drift apart. Cortisol rises with timing. Melatonin retreats with timing. Body temperature, insulin sensitivity, alertness, and the urge to sleep all begin obeying a shared schedule only when that light cue arrives with enough strength and at the right time of day. Every yawn you suppress in the morning, your body is settling a dispute between clock time and photon time. This is why late-night screens feel weak compared with dawn, even when they look bright. Illuminance, the amount of visible light hitting a surface, does not capture the whole mechanism. Spectral composition, the exact mix of wavelengths in the light, and timing in relation to your internal clock matter more. Morning skylight contains the wavelengths that melanopsin reads most efficiently and delivers them when your circadian system is ready to lock onto them. Your body does not ask whether the light feels poetic. It asks whether the signal arrives on time. In 1997, Joseph Takahashi and colleagues helped establish the central role of clock genes in mammalian circadian timing, showing that daily rhythms depend on molecular feedback loops rather than vague habits or simple fatigue. That mattered because it placed sunlight in direct contact with gene regulation. The day outside does not merely accompany your biology. It enters it. Morning is not atmosphere painted gold. Morning is an instruction set moving through your eyes into every tissue that still needs to know what hour it is. That is not a metaphor, that is the mechanism. Every morning you wake, your hormones obey a star before they obey your plans. And if timing depends on the exact wavelengths that reach you, then the sky itself has been choosing what parts of the sun you ever get to meet. What daylight erases daylight at the ground is edited sunlight. That contradicts the easy image of a clean beam pouring from the sun to earth untouched, because the light you live under has already survived a violent selection process before it reaches your skin. Cover one eye with your palm and look at the blue of the sky with the other. What you are seeing is not the color of empty space. It is evidence that molecules in the atmosphere have been redirecting short wavelengths out of the direct beam. Rayleigh scattering is the mechanism. That phrase means small molecules in air, mostly nitrogen and oxygen, interact more strongly with shorter wavelengths than with longer ones. So blue light scatters across the dome above you, while redder light keeps more of its original direction. Ozone performs a second edit. Ozone is a molecule made of 3 oxygen atoms, and in the upper atmosphere it absorbs a large fraction of ultraviolet radiation that would otherwise strike DNA directly. In physical terms, the sky protects you by spending solar energy before your cells have to. You do not walk beneath raw sunlight. You walk beneath filtered sunlight, scattered sunlight, sunlight with dangerous parts removed and useful parts redistributed. Gordon Dobson built the spectrophotometer that allowed 20th century scientists to measure atmospheric ozone precisely, turning an invisible shield into a quantity that could rise, fall, and fail. That mattered because the atmosphere stopped being abstract air and became a physical filter with measurable consequences for life below it. Without that filter, your skin would not merely tan or burn, your genetic material would break faster than repair systems could keep pace. The sunlight nobody talks about is the part your atmosphere never lets you see. That is not a metaphor. That is the physics. Every breath you take, the sky above you is finishing a negotiation between stellar radiation and cellular survival. There is an emotional fact hidden in that negotiation. Your life depends on a narrow corridor of wavelengths reaching a fragile animal body in exactly the wrong amount to wound and exactly the right amount to regulate. Think about that. To understand why that corridor exists at all, you have to stop treating sunlight as brightness and start treating it as a physical structure with rules. What you are really standing in sunlight is electromagnetic structure moving through space. That conflicts with the ordinary feeling that light is just what makes things visible, because visibility is only the side effect your nervous system happens to care about. Hold your hand out in the light again. The brightness on your skin does not consist of color alone. An electromagnetic wave is a traveling disturbance in electric and magnetic fields, and those fields oscillate at right angles to one another while carrying energy forward at the speed of light. In plain terms, sunlight is a self-propagating pattern of field change that does not need air to travel and does not ask matter for permission until it collides with it. When matter does absorb it, energy transfers in discrete packets called photons. That transfer carries momentum as well as energy. Momentum means light can push. The push is tiny in daily life, but it is real enough to move dust tails from comets and measurable enough to prove that light is not an ornament laid over matter. It is part of the machinery that acts on matter. The visible band matters to your senses because the chemistry of your retina evolved to respond there, yet the underlying object reaches beyond what your eyes can register. Infrared warms, ultraviolet cuts chemical bonds, and the visible range sits between them as the portion life on Earth learned to exploit most elegantly. Press your palm against a sunlit wall. The warmth you feel is one expression of electromagnetic transfer. The clock signal in your eye is another. The pressure on a dust grain in space is another. One object, many consequences. In 1901, Ernest Nichols and Gordon Hull measured radiation pressure directly, detecting the tiny force that light exerts when it strikes a surface. That mattered because it converted poetic language about sunbeams into mechanics. Light did not merely reveal the world, it pushed on it. Sunlight is not the stage lighting of reality. It is one of reality's moving parts. That is not a metaphor. That is the physics. Every step you take across a bright room, you cross a flow of momentum as well as color. But if sunlight is a physical structure, then the most revealing thing about it is not what your eye sees. It is what certain wavelengths are missing. Fraunhofer the answer in the lines sunlight contains the sun's chemistry written as absence. That sounds backward because darkness inside a spectrum looks like loss, and loss rarely feels informative. In sunlight, absence is the fingerprint. A spectrum forms when a prism or diffraction grating spreads light by wavelength, so that different colors land in different places. Joseph von Fraunhofer did this with extraordinary precision in the early 19th century and found hundreds of dark lines crossing the rainbow. Those lines were not stains in the glass or flaws in the instrument. They were absorption lines. An absorption line forms when atoms in cooler gas above a hot source capture photons of exact energies that match the spacing between allowed electron states. In physical terms, electrons inside atoms cannot occupy just any energy. They can sit only on specific rungs. When incoming light carries exactly the right amount of energy to move an electron from one rung to another, the atom removes that wavelength from the beam. The dark line is not empty, it is evidence that matter chose. Fraunhofer published his maps in 1814 and labeled prominent lines with letters, turning sunlight into a coded document long before physics learned how to read the code. He possessed the right data. He did not possess the answer contained in it. Later work by Gustav Kirchhoff and Robert Bunsen connected those lines to specific elements, proving that the same atomic rules operated in flames on Earth and in the atmosphere of the Sun. The irony is plain in the record. Fraunhofer spent years measuring the exact signatures of solar matter while lacking the conceptual key that would tell him what he had been looking at. This is the science nobody explains. The dark marks in sunlight are matter confessing itself through subtraction. That is not a metaphor. That is the physics. Every time light passes through gas, atoms announce their presence by deciding what cannot continue. Fraunhofer's lines solved one mystery and opened a larger one. If sunlight carries the signatures of atoms in the sun, then the light hitting your face today is not just local weather or daytime brightness. It is stellar interior history arriving in a filtered, delayed form you still have not fully met. Solidified escape sunlight on your skin is ancient escape from a star. That sounds dramatic only because daily repetition hides the timescale. The beam that looks immediate to you belongs to a process that began long before this morning. Set a timer for 8 minutes and 20 seconds. That is the easy part of the journey, the vacuum crossing from the solar surface to Earth. The hard part happened first. In the sun's core, nuclear fusion forces hydrogen nuclei together under enormous temperature and pressure until they form helium and release energy. Fusion means mass converts into energy according to strict conservation laws, and that energy first emerges in high-energy photons inside plasma so dense that light cannot travel straight through it. Plasma is matter stripped into nuclei and electrons, and in the solar interior it turns the sun into a luminous maze. A photon created there does not fly cleanly outward. It ricochets through endless absorptions and re-emissions, changing energy, changing direction and diffusing outward in a random walk that takes far longer than the final sprint across space. Your noon sunlight looks instantaneous because the last 8 minutes erase the previous ages from your senses. Astrophysicists Jos Bland Hawthorne and Catherine Fries have described the radiative diffusion time from the core to the surface as spanning roughly 10,000 to 170,000 to 170,000 years depending on the model and the photon's changing path. The measurements exist, the debate is about scale, not about whether the phenomenon is real. What matters for you is that the light warming your face left the photosphere minutes ago and began escaping the sun long before human memory. Sunlight is the sun escaping itself. That is not a metaphor. That is the physics. Every afternoon you stand in radiation that spent ages fighting its way out of stellar matter before it crossed the final distance fast enough to fool you. And once that escape reaches Earth, life does not merely receive it. Life captures it, stores it, and builds entire ecosystems out of the delay. Leaves, solar memory. A leaf stores sunlight as chemical separation. That upends the lazy picture of plants basking quietly in warmth, because photosynthesis is not passive soaking. It is charge management under extreme precision. Pick up a leaf if one is near you, or hold any green thing close enough to see the color deepen. Chlorophyll looks green because it does not keep green light efficiently. It absorbs red and blue wavelengths and uses that energy to excite electrons. Excitation means an electron jumps into a less stable state where it can move more freely. In the reaction centers of photosystems, protein complexes embedded in the thylakoid membranes of chloroplasts, that excited electron does not simply fall back and release heat. The system pulls positive and negative charge apart fast enough to prevent recombination. In plain language, the leaf uses sunlight to tear electrons away from their comfortable arrangement and route them into an electron transport chain. a sequence of molecular handoffs that pumps protons across a membrane and builds an electrochemical gradient. That gradient is stored disequilibrium. It is difference held in place. Later, the cell spends that difference to make ATP and reduce carbon dioxide into sugars. The leaf is not collecting light as a surface effect. It is converting photons into organized chemical tension. In 1937, Robert Hill showed that isolated chloroplast preparations could release oxygen under light when provided with the right electron acceptor, proving that the light reactions of photosynthesis physically split the process into energy capture and later carbon fixation. That mattered because sunlight ceased to be an abstract life force and became an electron-moving mechanism. Plants do not admire daylight. They arrest it. A leaf is solar memory with veins. That is not a metaphor. That is the chemistry. Every meal you eat, you consume electrons that sunlight once lifted into unstable positions and life refused to let fall back. This is where the scale widens. Your breakfast, a forest, the oxygen in your blood, and the carbon in your muscles all belong to one continuous accounting system. Sunlight is not an isolated beam landing on isolated organisms. It is a transaction passing through a network, and the atmosphere decides how expensive that transaction becomes. Putting heat in a glass cylinder. An atmosphere finishes what sunlight starts. That contradicts the feeling that the sun acts and Earth merely receives, because the planet does not sit under radiation like a passive rock. It processes the incoming energy and changes its meaning. Breathe onto a cool window if one is near you, and watch the fog bloom and fade. That small cloud reminds you that gases interact with radiation selectively, not generically. The greenhouse mechanism begins when shorter wavelength sunlight passes through the atmosphere and warms the surface. The surface then emits longer wavelength infrared radiation upward. Carbon dioxide, water vapor, and methane absorb parts of that outgoing infrared because their molecular vibrations match those photon energies. A molecular vibration is a patterned motion of bonded atoms, and when the energy fits, the gas takes the photon, changes its internal motion, and later re-emits energy in new directions. In physical terms, the atmosphere slows the planet's loss of heat to space. It does not create energy, it traps a portion of the outflow and thickens the thermal blanket around everything alive beneath it. In 1856, Eunice Foote placed different gases in glass cylinders, pumped air from them, set them in sunlight, and watched the thermometers rise. The cylinder filled with carbonic acid gas, what we now call carbon dioxide, heated more strongly and cooled more slowly than ordinary air. That was the moment of proof. Glass, sunlight, mercury, a visible climb of temperature. Yet Joseph Henry presented her paper to the American Association for the Advancement of Science, and her results slipped to the margins while later men received the durable credit. Her hypothesis was right. The institution around it failed to lift it. The sky is not empty distance. It is an active thermal organ wrapped around the planet. That is not a metaphor. That is the physics. Every breath you take, your lungs borrow oxygen from a biosphere and warmth from an atmosphere that sunlight keeps negotiating into habitability. What happened next on a larger scale carried far more violence than habitability suggests. And one September morning in 1859 proved that the sun never stopped reaching past climate into the machines we thought were ours alone. The white flare, the sun can reach across space and break human systems in a day. That collides with the domesticated image of sunlight as harmless daylight. Because the same star that sets your clock and feeds your food also throws magnetic violence outward on timescales. Your nervous system never learned to fear. Look at the nearest wire, charger, or power line you can see. Electricity feels local because we build the circuit ends, yet the planet itself sits inside a larger electrical environment shaped by the solar wind and the sun's magnetic field. A solar flare is a sudden release of electromagnetic energy from a stressed magnetic region on the sun. A coronal mass ejection is a vast cloud of magnetized plasma hurled into space. When that magnetized plasma strikes Earth's magnetosphere, currents surge through the upper atmosphere and can induce current in long conductors at the surface. Induction means a changing magnetic environment forces electric charge to move in nearby materials. In physical terms, the sun can write electricity into your technology without touching it directly. On September 1, 1859, Richard Carrington projected the sun's image onto a screen while observing sunspots and saw an intense white flash erupt inside one active region. Hours later, telegraph systems across Europe and North America failed, sparked, shocked operators, and in some offices ignited paper. Carrington had witnessed the optical sign of the disturbance before its full planetary consequence arrived. The loss was not metaphorical. The damage traveled through real wires, real desks, real hands. A star 8 light minutes away sent a disturbance that entered human infrastructure and set it trembling. Sunlight is not a beam, it is membership in a star's field of consequence. That is not a metaphor, that is the physics. Every civilization you build under the sun remains electrically subordinate to the object that powers it. The emotional force here comes from scale. You live inside systems that feel human-sized only until the sun reminds them whose energy gradient made them possible in the first place. Think about that. And the same star that can overload wires can also strike your cells softly enough to accumulate damage one bond at a time across the length of your life. What ultraviolet cuts ultraviolet light injures your DNA with geometric precision. That complicates the ordinary story of sun damage, because the real event is not cosmetic, not even at first. It is architectural. Look at the back of your hand. Underneath the color and texture, keratinocytes in your skin hold DNA packed into chromosomes, long molecules whose sequence remains useful only if the chemical bases stay readable. Ultraviolet photons carry enough energy to create cyclobutane pyrimidine dimers, lesions in which adjacent pyrimidine bases, often thymine, bond to each other when they should not. In plain terms, the photon strikes, electrons shift, and the ladder of genetic information kinks into the wrong shape. Replication machinery then reads damaged terrain. Repair systems intervene, and if they fail or miss enough lesions, mutation accumulates. Melanin helps by absorbing and redistributing some energy before the DNA takes the hit, but melanin is a partial shield, not a repeal of physics. Every hour you spend under strong ultraviolet, your skin conducts a triage operation between incoming damage and available repair. Aziz Sankar's work on nucleotide excision repair clarified how cells locate and cut out bulky DNA lesions, showing that damage does not merely happen and stay. The cell patrols, removes a segment around the injury, and rebuilds it using the intact strand as a template. That mattered because the scar from sunlight moved from the realm of vague warning into direct molecular process. Your skin is not passively weathering daylight, it is constantly correcting it. Sunlight can build your timing and threaten your sequence in the same body on the same day. That is not a metaphor, that is the biology. Every blink you make in bright daylight, your tissues are dividing the same solar stream into signal, heat, and hazard. The harder mirror arrives when you realize this is not only about summer or exposure. Aging changes the balance. Repair slows, lenses yellow, circadian amplitude weakens, and the same morning light that once snapped your system into place begins meeting a body that answers less sharply. The clock beneath your skull, aging, is partly a failure to keep time across your own tissues. That does not mean clocks cause all aging, and it does not need to. It means the body loses coordination before it loses existence. Place your fingertips lightly against your temple and feel the pulse there if you can. Rhythms govern living systems at every scale. Hormone release, immune traffic, body temperature, blood pressure, digestion, alertness, sleep pressure, and the expression of repair genes. Circadian amplitude is the strength of those daily oscillations. In physical terms, it is the difference between a strong, well-timed rise and fall and a flattening pattern that blurs day into night. Light arriving at the wrong time weakens that amplitude. Morning light strengthens it. When the suprachiasmatic nucleus receives a robust daylight signal, it coordinates peripheral clocks more cleanly. When signals grow weak, irregular, or late, tissues drift. Drift means organs stop changing state together. Glucose handling misaligns with feeding. Immune responses mistime themselves. Sleep fragments. Repair and wear stop taking turns with clean boundaries. Sachin Panda and colleagues help demonstrate how tightly biological timing links to patterns of light, feeding, and rest, making circadian disruption measurable in metabolism rather than sentimental in tone. That mattered because good routine stopped being lifestyle advice and became temporal physiology. Your clock is not a metaphorical balance. It is a distributed timing system with biochemical parts. You do not age only by losing cells. You age by losing synchrony. That is not a metaphor. That is the biology. Every evening you stay under artificial brightness, and every morning you miss real daylight. Your body pays with a little more internal disagreement. This is where the rectangle of sun on the floor returns. It was never decoration, it was a daily offer of alignment. Carrying the same stellar escape Fraunhofer measured in dark lines, the same filtered corridor the atmosphere defended, the same energy leaves store and weather redistributes, and the same ultraviolet risk your cells spend themselves repairing. The final step is not another mechanism. It is seeing the whole thing at once and admitting what remains unequal between the star and the body standing under it. The mortality mirror, you now stand in sunlight with a different body than the one that entered this discovery. You know that within the first 90 seconds of morning exposure, melanopsin in your retinal ganglion cells can begin resetting the suprachiasmatic nucleus, while 7-dehydrocholesterol in your skin can start a second chemistry of conversion. You know the atmosphere has already edited that beam through Rayleigh scattering and ozone before it ever reaches you. You know the brightness on the floor is electromagnetic structure carrying momentum, the same physical object, Nichols and Hull, measured as pressure, and the same coded spectrum, Joseph von Fraunhofer, mapped without knowing he held the sun's chemistry in missing lines. You know that light itself spent ages escaping stellar plasma before racing the final 8 minutes to Earth. You know leaves arrest that escape by separating charge and storing it in carbon compounds. You know Eunice Foote watched carbon dioxide hold solar heat in glass. You know Richard Carrington saw the white flare before telegraphs burned. You know ultraviolet can kink your DNA while repair systems race behind it. And you know your own tissues age not only by damage but by drift, losing synchrony under the same star that keeps arriving. The sun keeps delivering structured energy with brutal consistency. Your biological limitation is that your cells, lenses, repair systems, and clocks lose precision while the morning signal remains physically exact. Understanding sunlight this way does not drain wonder from it. It restores wonder to its rightful scale by proving that beauty survives contact with mechanism and becomes deeper when you can name the forces inside it. You have stood in morning sunlight and let an ancient star reset your body before you felt warm. Step into the next patch of morning light and stay there for 1 full minute with your eyes on the bright sky, not the sun. Not because it is spiritual, because it is physics.